Jungle.
Good day everyone, I am Giancarlo Bordon together with John Patrick Barona and Ninia Maria Pitong, and we're going to discuss about robots and other motion control systems. So first, we need to know what is a robot. A robot is a machine that is programmable by a computer that is capable of carrying out a complex series of actions automatically. It can be guided by an external control device or it may be embedded within. It may be reconstructed to evoke human form, but most robots are task-performing machines that are designed with an emphasis on stark functionality rather than expressive aesthetics. So here are the common types of robot. The mobile robots, stationary robot, autonomous robot, and remote-controlled robots. First, the mobile robots. Mobile robots is a machine controlled by software that use sensors and other technology to identify its surroundings and move around its environment. Next, stationary robots. Stationary robots are robotic arms designed for tasks like picking and placing, sorting, assembling, welding, and finishing. Next is the autonomous robots. Autonomous robots have the ability to gain information about their environments and work for an extended period of time without human intervention. Remote-controlled robots. A robot that is teleoperated by any transmitting device, which in most cases is a remote. So a robot has three main components. So the first component is the sensor. Sensors are what allow a robot to gather information about its environment. The information can be used to guide the robot's behavior. So example nada is camera, buttons, barometers, supersonic, magnetometers, microphones, thermometers, light detection and ranging or the LDR, and accelerometers. Next component is the effectors. Effectors are the parts of the robot that actually do the work. It can be any sort of tool that you can mount on your robot and control with robot's computer. Most of the time, the effectors are specific to the task that you want your robot to do. End effectors. End effectors are tools at the end of the robotic arms and other robotic appendages that directly interact with objects in the world. Motors can be used for many of the moving parts of a robot. From joints on robotic limbs to wheels on robotic vehicles to the flaps and propellers on a robotic airplane. Pneumatics and hydraulics. This is used when a robot needs a lot of strength to perform a particular task. Next, speakers. Speakers can allow certain robots to talk to us or generate other sounds. The next component is the control systems. A robot's control system is the part of robot that determines the robot's behavior. Pre-programmed robots. The very simplest pre-programmed robot merely repeats the same operations over and over. Such a robot is either insensitive to changes in its environment or it can detect on very limited information about very limited parts of the environment. Such a robot will require little in the way of controls, but it will perform properly only if the environment behaves in accord with the robot's pre-programmed actions. Next is the autonomous robots. More complex robots are able to respond appropriately in environments that are much more complicated. Such a robot will have sensory apparatus that allow it to detect changing features of the environment and range of behaviors that will allow it to respond to those changes. Whatever features of the robot enable it to adapt its behavior to its environment, we will call the control system. So there are two kinds of control systems. First is the top-down. Build the brain first. Then hook up the sensors and the effectors. If the brain is built properly, it will take the input data from sensors and be smart enough to behave intelligently in response to it. You build a brain by writing an artificial intelligence computer program. There are two main kinds of AI programs, the classical AI and the connectionist networks. Next is the bottom-up. Don't bother with the brain. Hook each sensor directly to an effector. Call this a behavior. Then rank each of the behaviors in order of priority to determine which one wins out and controls the robot if more than one is activated. Call this ranking a hierarchy. Most hierarchies produce stupid robots, but just the right hierarchy can produce remarkably intelligent behavior. These are also called behavior-based robots.
Next, we have the robot configuration.
Robot configuration. When selecting an industrial robot, there are many things which need to be considered, such as what is its purpose, how fast does it need to move, what precision of movement does it need, and will it be a collaborative robot? One of the major factors which determines how an industrial robot will move and what limits its workspace is its robot configuration. There are 6 major types of robot configurations: Cartesian, cylindrical, spherical, selective compliance articulated robot arm or SCARA, articulate, and delta or parallel. Some industrial robots may not be able to scratch the back of their forearm with the same hand, just like most people cannot perform this task. However, through the attention to access and the selection of a configuration, industrial robots can be designed to move their tools quickly, accurately, and repetitively to any point within a 3-dimensional workspace. In this slide, you can see a table with their robot configuration, explanation, and their common uses. First, we have the Cartesian. A Cartesian has a robot's tool moving in a linear motion along each of the Cartesian coordinates x, y, and z. This type of configuration can sweep out a box-like work envelope. For the common uses of a Cartesian robot configuration, it is usually used in many 3D printers that have their print nozzles mounted on a Cartesian configuration. The second one is the cylindrical robot configuration. It allows its tool to rotate around a central axis. The tool can also move towards and away from the central axis, plus up and down the central axis. This configuration creates a work volume in the shape of a cylinder. The common uses for the cylindrical robot configuration is that this configuration is typically used for assembly operations, handling of machine tools, and die-cast machines, and spot welding. The next one is the spherical robot configuration. The tool motion created by this configuration sweeps out a workspace shaped like a sphere. It has its tools rotate around a central axis, and the tool can also rotate around a second axis, which is placed at a 90-degree angle on the central axis. In addition, the tool can move back and forth along an axis. For the common uses of a spherical robot configuration, they are commonly used for die casting, injection molding, welding, and material handling. The next robot configuration, the SCARA or the Selective Compliance Articulated Robot Arm. It uses a pivot points to allow its tool to move in a combination of a Cartesian and the cylindrical motions. This allows the tool to move more quickly and move more easily in certain motions, such as moving an arc. The common uses of a SCARA robot is that they are used in assembly and palletizing, as well as biomedical applications. Next is that we have the articulated robot configuration. This type of robot is the most commonly pictured when referring to an industrial robot. As a minimum, it needs to have at least a shoulder joint, an elbow joint, and a wrist joint. Many examples of this configuration have both major and minor axes. For the uses, we use an articulated robot configuration. For typical applications for articulate robots are assembly, arc welding, material handling, machine tending, and packaging. The VEX V5 work cell is an example of an articulated configuration. Lastly is that we have the delta or the parallel robot configuration. It can move the robot's tool the fastest of all of the robot configuration types. It uses parallel linkage to allow its tool to quickly sweep out its workspace. A delta can nimbly and quickly pick and place items in a sorting task, as well as serve in many other functions. To add more description about the 6 major types of robot configurations, in this slide you can see a Cartesian robot and its details, more details from the previous slides. So it consists of 3 or more linear actuators assembled to fit a particular application. They can be elevated to maximize floor space and accommodate a wide range of workpiece sizes. It typically uses standard linear actuators and mounting brackets. The custom nature of a Cartesian robot is that to make a design, specification, and programming challenging or out of reach for smaller manufacturers intent on a DIY approach to robotics implementation. Next is the cylindrical robot, which allows its tools to rotate around the central axis. The tool can also move towards and away from the central axis plus up and down the central axis. Their configuration creates a work volume in the shape of a cylinder. Bali, amo ni siya ang daw cylinder iyang shape sa iyang work envelope nag-achieves with rotating shaft and may ara siya extendable arm na makamove vertical and in sliding motion. Amo pa gini siya ang ginagamit sa gagmay nga space or workspaces kay mas simple siya i-assemble kag gamay lang siya. Amo na nga daw mas hapos kag mas space saving siya sa workspaces. Next type of robot configuration is the spherical robots. So this type of robots, or the tool motion created by this configuration, sweeps out a workspace shaped like a sphere. It has its tool rotate around the central axis, and the tool can also rotate around a second axis, which is placed at a 90-degree angle on the central axis. In addition, the tool can move back and forth along an axis. Bale, this type of robot may are siya 2 rotary joints and 1 prismatic joints. So bale, in other words, there are 2 rotary axes and 1 linear axis. Ang spherical robots may are siya nga arm nga form a spherical coordinate system. It's advantageous to use this if gusto mo nga mas dako ang range sing imo nga hulagan sing imo nga robot. Kay first, they are maneuverable, tapos they are also designed to be holonomic, so they can move in any direction. Next type of robot configuration is the Skyro robot, which is the selective compliance articulated robot arm. So this kind of robot excels at vertical assembly tasks such as inserting pins without binding due to their vertical rigidity. These robots are lightweight and have smaller footprints, making them ideal for applications in crowded spaces. They are also capable of very fast cycle times. So, ang Skyro robot, amo ni siya ang ginagamit for pick and place or assembly operations, wherein nga need mo ang high speed and high accuracy. Kay ang Skyro can operate at a higher speed with optional cleanroom specification. Second to the last major type of robot configuration is the articulated robots. So these robots are classified by the number of points of rotation or access they have. They can easily reach into a machine tool compartment and under obstructions to gain access to a workpiece. Articulated robots are less suited than other types of robots for very high-speed applications due to their more complex kinematics and relatively higher component mass. So, an articulated robot is a robot with rotary joints, that can range from simple two-jointed structure to systems with 10. Tapos, they are also good at assembly application since ang ila joints gina-allow sila nga maka-move in a way nga ang iba nga robots hindi maka-move sa amo na nga situation. And they are also precise enough even sa small assembly tasks. Lastly is the Delta robots, which also referred as spider robots, where they use 3 base-mounted motors to actuate control arms that position the wrist. Basic Delta robots are 3-axis units, but 4 and 6-axis models are also available. A Delta robot's arm can be very lightweight. This allows for rapid movement, which makes Delta robots ideal for very high-speed operations involving light loads. Delta robot is typically defined by the diameter of the working range. So Delta robots are mainly used in applications wherein the robot is picking products in groups and placing them in a container or in an assembly pattern. Another description is that the Delta, or the name Delta from the Delta robot, comes from its upside-down triangular shape. As you can see in the picture, do makita nyo ang iya shape nga gapa-triangle. That is why gintawag siya nga Delta robot. In this slide, we have calibration term, which means it is the movement to a calibration point. And the calibration point, na siya a measurement that require a starting point or 0 point. Nga may calibration, it is very important for a robot to be calibrated para they can use a standard point to measure their movements in order to define their movement in the space. So measurements sa robots are very essential since amo na siya ang means nga ma-verify sing system if na-meet ang requirements nga need nga obrahon sing mga robot. Next we have here is the work volume or work envelope. So this is the workspace that a robot sweep through. It is not only defined by the robot's axis, but the structure of a robot can also define its motion. For instance, a robot's wrist might be able to make a full rotation, but its arm might block a tool on the wrist from making a full turn. So, ang area nga hindi mahulagan sing robot is called a singularity.
Meanwhile, on robot software, it is the set of coded commands or instructions that tell a mechanical device and electronic system, known as robot, what task to perform. It is used to perform autonomous tasks. Many software systems and frameworks have been proposed to make programming robots easier. Some robot software aims at developing intelligent mechanical devices. Common tasks include feedback, loops, control, pathfinding, data filtering, locating, and sharing data. On the other hand, in industrial robot software or software for industrial robots consists of data objects and list of instructions known as program flow or list of instructions. For example, go to jig 1. It is an instruction to the robot to go to positional data named jig 1. Of course, programs can also contain implicit data. For example, tell axis 1 to move 30 degrees. Data and program usually reside in separate sections of the robot controller memory. One can change the data without changing the program and vice versa. For example, one can write a different program using the same jig 1, or one can adjust the position of jig 1 without changing the programs that used it. So now we will discuss the 7 types of robotic software. So one of the types of robotic software is offline programming, whereas it provides a way for you to program the industrial robot without needing to be physically connected to the robot at the time. It reduces downtime, improves the quality of programming, and allows you to change between product lines quickly, among other benefits. Second is a simulator, which are robot simulators come in many forms. Some only allow for simple 2D simulation of specific aspects of robotics, while others include 3D simulation with complex physics engines and realistic environments. The third one is middleware, one of the most misunderstood types of robot software. It provides a framework for running and managing complex robot systems from a single unified interface. Some people describe it middleware is the software glue that helps robot builders to avoid reinventing the wheel when they are designing a new robotic system. Meanwhile, the fourth one is mobile robot planning. Mobile robots are programmed in a different way from other robots, which means using a different type of software too. The fifth one is real-time path planning. A path planning software is used in many areas of robotics. Basic path planners like our PRM feature are simply used to speed up the programming phase for industrial robotics. It is much more complex than basic path planning because it involves continually updating the program to respond to change in the environment. This allows the robot to be reactive but can also make the robot more unsafe. The sixth one is the UAV or drone control. A growing type of robotic software is drone control. This refers to any software which is used to program and coordinate unmanned aerial vehicles. Software for drones tends to focus on particular application areas or aspects of drone control. Lastly, the artificial intelligence for robots. Artificial intelligence or AI has been used with robotics for many years, almost as long as robotics have been around. However, there has recently been a rising number of software solutions specifically for using AI with robots in particular application areas. As with the other types of robot software, AI tends to be focused on specific aspects of these applications, such as analyzing images collected in agricultural settings, filtering operational data in manufacturing environments, or coordinating swarms of mobile robots in logistics. And we're now in robot application software, where an application includes command and control and tasking software. Command and control software includes robot control GUIs for teleoperated robots, point-and-click command software for autonomous robots, and scheduling software for mobile robots in factories. Tasking software includes simple drag and drop interfaces for setting up delivery routes, security patrols, and visitor tours. It also includes custom programs written to deploy specific applications. General-purpose robot application software is deployed on widely distributed robotic platforms. To end our discussion, here are the other robotic programming languages. First is the visual programming languages. It's any programming language that lets user create programs by manipulating program elements graphically than textually. Meanwhile, the second is scripting languages. It's a high-level programming language that is used to control the software application and is interpreted in real time or translated on the fly instead of being compiled in advance. May be a general-purpose programming language, or it may be limited to specific functions used to augment the running of an application or system program. It is also usually a streamlined list of program commands that are used to simplify the programming process and provide rapid application development. And lastly is the parallel languages. Parallelism is where the robot does two or more things at the same time. This requires appropriate hardware and software. Most programming languages rely on the threads or complex abstraction classes to handle parallelism and the complexity that comes with it, like concurrent access to shared resources. So guys, that's the end of our discussion. Thank you so much for watching. Goodbye!